Okay guys, so welcome to today's session. So in today's session I want to start and finish cubic sequences, and I'm going to give 3 different examples on finding the nth term of a cubic sequence. So if you've been following me nicely, we started with linear, then we looked at quadratic, and then today we want to look at cubic sequence. So the difference is just 1. So we are saying in a cubic sequence, it is the third difference that would be the same. So those of you who've been following me, you know what I mean by that. And I want to say the format for the nth term, all right, the nth term of a cubic sequence is an cubed plus b. It can be c if you want. And I want to say that how we find a for a cubic sequence is that a would be the third difference divided by 6. I'm not going to go into the technicalities of explaining to you why we divide by 6. For now, just take this as one of your notes. And then b can be anything, a quadratic equation, a constant, or the nth term of a linear sequence. So all these things, we'll look at them in the following examples that will be coming. So I just want you to remember that a is given by the third difference divided by 6. In future, we'll explain why it's like this, but for now, let's just get the basics. So let's look at the first difference between this sequence that is given here between terms. So the difference between 0 and 7, negative 7, that would be plus 7. The difference between 19 and that 0 would be plus 19. The difference between 56 and 19 would be plus 37, and then the difference between 117 and 56 would be plus 61. So the differences there are not the same, so we look at the second difference here. So the second difference here, which comes to plus 12, and then this one gives us plus 18, this one gives us plus 24. So you can see that even the second difference here is not the same. So let's look at the third difference here. The third difference here would be plus 6, and then the third difference there would be plus 6. So this is the D3. And if this is the same, we conclude saying this is a cubic sequence. Now, the idea is to find the A and the B in order for us to come up with the formula that someone was using to come up with these different terms, which is negative 7, 0, 19, 56, and 117. So what I've said is that A should be third difference, which in this case is 6 divided by 6. So our A would be equal to 6 divided by 6, giving us 1. And right away, our nth term starts looking like this. For now, our nth term is now 1 times n cubed plus some constant or equation b. So if we look at this nicely, this should be n cubed plus b. So now, what we are going to do to find b, we need to draw a diagram of some kind, or a table like this one here. So I've already done this for you. This is for position where terms would sit. This is just going to be 1, 2, 3, 4, 5, and 6 if you want. Then here we should put terms of the given sequence. So we've got negative 7 sitting on position 1, 0 sitting on position 2, 19, and then 56 and 117. So we didn't actually need to have that 6 there. So now what we put in the third row here should be the sequence of n cubed. So for n cubed, it means we are cubing we are cubing the position. So 1 cubed would give us 1, 2 cubed would give us 8, 3 cubed should give us 27, if I'm not mistaken. 3 cubed, let me just confirm, 3 cubed gives us 27. So 3 cubed gives us 27. 4 cubed gives us 64. And 5 cubed gives us 125. All right, so Now, once we are done with this, all we need to do is to subtract the difference between the n cubed sequence and the given sequence. So doing that, we are going to see that if we subtract these two sequences, the difference between the two sequences in this case would be -7 minus 1 would give us -8. Even 0 minus 8 would give us -8, -8, -8, -8. So if the difference between the two sequences is a constant, this is what we need to add to the n cubed in order for us to find the nth term. So right away we can conclude and say, therefore, the nth term, all right, the nth term of this sequence would be n cubed, take away the common difference, which is this which we are finding. So this is how we find the common, the nth term of a given cubic sequence. It is there for you to try and see if this formula works. So let's say let's see if n is equal to 1, this formula here should give us -7, sorry. So you'd find that you are going to do 1 cubed, take away 8, which then gives us 1 take away 8 to give us 7, -7. So you see that this is true for all the other terms. For example, if you want, you can pick on 0, which is on position number 2. So that means now this sequence is going to be 2 cubed, take away 8. 2 cubed is 8. 8 minus 8 gives us 0. So this is the nth term, and it is working. So what I want to say in this first example is that the general form of a cubic sequence is this one here that I've written to say a times n cubed, because it's a cubic sequence, plus b. Now a is always found by dividing the third difference divided by 6. So if the third difference is 24, whatever you're going to get, you divide it by 6 to find what a is going to be. Then b is the formula of the difference that you are going to find between the two sequences. So we'll look at that more in the second example, but I just want you to take a few takeaways here to say nth term, the general formula of the cubic sequence, would always be equal to a cubed, a times n cubed, plus b, where a is found by dividing the third difference by 6. It's always true. We'll look at why we divide by 6, and that will come later when we are more familiar with finding the nth term of a cubic sequence. So guys, thank you very much, and please watch out for the second example and the third example that I'm going to give on cubic sequences. Please, it will be coming shortly. And please like and share my videos if your students, if you're a teacher, and if you're a student, you can recommend it to your colleagues. So guys, thank you very much for your time, and please let's look at the third example, the second example.